Janice. All right. So let me get started by, again, I introduced Dave and Craig already, and just want to refresh and get us thinking about the Water Action Volunteers program as a whole, and that our goals are to educate and empower the citizens of Wisconsin so that you all understand what we do on the land, how it affects water quality. We also want to get high quality data that can be used by the Department of Natural Resources or other entities, counties or local municipalities or local groups for decision making, and we want to encourage that data are shared and knowledge is shared. So with that in mind, I asked the question, why did WAVE change our habitat methods? And I wanted to explain that to you all. One of the most often asked questions that I get, and I think Lindsay Albright gets too, is how are our data being used by the department? And one of the things with the former habitat assessment is it was set up for use by the volunteers. It wasn't something that was used by the department staff, and so the numbers that the volunteers are reporting don't necessarily immediately mean anything to the department staff. So this method that we're using now is the qualitative habitat assessment that the Department of Natural Resources water quality biologists are using at their sites, and it's exactly the same as what they do, so that when you all collect information and get a number, get an answer, that actually means something without the biologists having to think and process and try to figure out what those numbers mean, because it's exactly what they do. Apples to apples can be compared. So let me go through what is the same between the old habitat assessment and the new habitat assessment, and then I'll go into what's different. So what is the same? So one of the things that's not changed is that habitat will be assessed one time per year once the vegetation is out and full. So June, July, August are great times of year to do that. But again, just like before, one time a year. And the assessment, like before, is subjective. So I have a couple of screen questions up here on the screen where you see that there are 4 options that you decide with, or in between, for each of the questions that you work your way through. The more diverse, or the better the habitat, the higher the score you would get for that particular question. So that's very similar to what we had you doing in the past. What's different? So with the old method, we had 2 different forms. One of the forms was for rocky bottom, and one was for soft bottom habitats. That is no longer going to be part of the deal. The new form, we actually have 2 forms again, but the forms are based on the average stream width. And I'll talk more about that in a little bit. The second thing with the old method is we had you looking at a 300 foot length of stream. And now the method that the biologists using the qualitative assessment, that actually is could be quite a bit longer depending on the width of your stream. The length to assess is 35 times the mean stream width. So that would be up into a maximum of 1,300 feet of stream length that you would assess, and I will talk more about that in a little bit as well. Third thing is that in the old method there was some information about what was happening on the left bank or the right bank, and in this new method we don't have to worry about left or right banks. And then the only other thing that with the new method, we need to measure stream width multiple times to figure out the average stream width. And then there's some new ratios that I'll go through with Craig and Dave to help you understand some of the new questions that have to do with some different terms and some new ratios that are considered. So the biggest difference is that if you cannot assess, either for safety reasons, for landowner permission reasons, for it's just too far, if you cannot assess the 35 times the mean stream width, then please don't collect habitat assessment at all. And the reason for that is that we really want the biologists and the volunteers to be doing the method in exactly the same way. And if we modified it for the volunteers, say to make it a shorter length, like in our old method, then it wouldn't necessarily be the way the biologists do it, and it could be that some information was missed by not going out the full length of the 35 times the mean stream width. So if you can't go the full 35 times the mean stream width, do not worry. Just don't go and assess habitat. So between the two forms, you have the choice of the mean stream width being less than or equal to 10 meters or less than or equal to 33 feet or greater than 10 meters or 33 feet. The way to figure out the average width is if you can measure at 10 locations along an extended length and then take the average. So my understanding, and Craig and Dave can speak up if this is incorrect, is that this is from a quantitative habitat assessment that the biologists do, and they do 10 transects along a length of stream. And so this measuring width at 10 points was sort of translated from that quantitative habitat assessment because that's what they're used to doing to figure out the width along in their quantitative assessment.
I would add, Chris, this is Dave, that typically we do 12 transects at each quantitative habitat survey. And it's from the road, you can get a pretty good idea what your average stream width is going to be. So it's good to space your transects out, or at least your measurements of the stream width out throughout the qualitative habitat survey station. But there's no, for the qualitative, there's no set distance that it has to be apart. It's just getting a good average stream width and then multiplying that times 35 to get your full stream width to walk.
Okay, that makes sense. Thank you. So I was looking through the data sheets to try to pull out some terms that I wanted to make sure that you understood. Some of these terms have been used on the old habitat assessment, and some of them are new. They are all explained in the habitat assessment methods, which I sent you a link to when I advertised for this webinar. So you can check back there. I did update this to align with this new DNR qualitative habitat assessment. So if you were trained a number of years ago, your habitat methods will be slightly out of date because you added some terms and added in the meaning of the water quality score that you get for this new assessment in an updated version. And again, that's posted online, and you got the link with the ad for this webinar. So the first term I wanted to talk about is the riparian buffer. And basically, riparian area is the land next to the stream or alongside the stream. So generally, it's, if you're not in the stream, it's where you're standing is in the riparian area. Then in any stream system, there's a sequence of what are called riffles, runs, and pools. And most of you are probably familiar with these terms, but just to be clear, a riffle is the area where there's rapid movement of the water. The water is generally breaking over rocks, it's turbulent, and it tends to be pretty shallow areas like in these photos. Runs, on the other hand, are when the water is still moving quickly, but it's deeper, and there tends to be less breaking of the water surface over rocks, or little to none of that information, or of that. And then pools, like you think of a swimming pool, these are the deep, slow water areas of the stream.
And I might add, this is Craig, regarding the pools. You will see a definite depth change between, say, a run into a pool, as well as you might see a little back eddying on the water. But you definitely see higher depth, slower movement, and again, back eddying.
Thank you. Okay, and then looking at one of the terms, we're looking at fine sediments versus rocky sediments. So fine sediments are your sands, silts, and clay. So all of these, as the pictures show, things that are very small in size, particle size. And the bottom pictures, they go left to right, sand, silt, and clay. The rocky substrate, on the other hand, are things that are bigger. So we have gravel. So those are 0.1 and up to 2 inches in diameter. Cobbles are bigger. They're 2 to 10 inches in diameter. Boulders are even bigger, greater than 10 inches. And then bedrock would be that real solid rock on the bottom of the stream. Then a new term that I had not introduced in the past, and this is one of the things that's been updated in the habitat assessment methods, is this term called the thalweg. I think it's a great word. It is the path of the deepest and fastest water in the stream. So if you happen to be somebody who canoes or kayaks, you probably follow the thalweg, and maybe you didn't know its name, but it's on the outside of bends, the figure in that sort of aqua color, the outside of the bends, and then crossing sort of the center where it's straight away, and then back on the outside and down the center. So oftentimes you can see the thalweg in a stream when you're standing on shore, though I did have difficulty finding an actual photo that you could actually see that water movement in the thalweg. Here's a picture that I thought was a neat way of presenting it, where it's winter, so the thalweg, the water is moving in that area of the deepest and fastest flow, so you can see where they've drawn in the line of where the thalweg is, which is where the open water is showing up in this particular stream. Okay, so what I wanted to do is to just work through the forms. Again, there's two forms. We've got the less than 33 feet and greater than 33 feet. Both of the forms have the same front side, if you will. So the information that you would need to fill out for the station summary includes your station name and your station ID. It's very important that you fill this information out if you're going to be turning your paper data sheets into anybody. If you don't, particularly your station ID, since people can have different ways of calling a station name, in our DNR SWIM database, it's named one way in the station name. But very, very important, the station ID number must be recorded because that's linking your station with a GPS coordinates and a county and literally getting you to that point. When you're entering the data into the online database, you're going to have a choice of a drop-down of your stations that you monitor, so it will be pretty easy for you to know that that is that station. But in the event that you're turning in your data sheets at the end of a year or to a local coordinator, it's really important that you have your station ID so that that person knows which station it is that you're actually monitoring. Then date and time, those are pretty basic. And anything here on this front side of these forms that's bolded is something that you must enter. So stream width, we talked about the measuring along the station length in a number, as Dave said, in a number of places that you can get a good average width. And then make sure you can enter it either feet or meters. Just make sure you circle which one it is that you have done. And then station length is 35 times the mean stream width, and again up to a maximum of 1,300 feet. For water level, you can circle, looks like the boxes to check are gone. You can circle, or I'll update that and get your boxes out there again. So normal, below, or above average. If you don't know, then just leave it blank. Water clarity, we're looking for clear, turbid, or stained, like tea-colored or tannic acid leaching in from the leaves. For the stained coloring, turbid would be with cloudiness if there's been runoff of sediments into the stream. And then the channel condition, is it a natural condition where you're seeing lots of meanders? Has it been straightened, or is it some kind of a concrete channel? If you have any comments or observations about the site that you want to share, there'll be a place in the database to enter your comments as well. Okay, so just working through the questions, I'm going to start with the less than or equal to the 33 feet or 10 meter width streams. And I think I'm going to we'll do it organically, Dave and Craig, if you guys want to share how you do this or whatnot. So for the riparian buffer, that again, the land beside the stream. So we're looking at, this is very similar to our old habitat assessment, the width of the undisturbed land alongside the stream. That's meadows, shrubs, woodland, wetland, exposed rocks. Dave or Craig, would you like to jump in and say anything about how you guys do this, or in choosing your excellent, good, fair, or poor option?
Well, I might jump in probably with two things. One, touching on access. With streams, and many times the land on either side of the stream isn't owned by our volunteers or who's out there. So when you're looking at the riparian area, you can either look at it, or if you're going to be literally measuring it, then you would need approval from the landowner. So if you can't get approval, you'll just have to go with estimating.
a great point. And we generally recommend, if you're getting approval from the landowner, is get that as written permission, not just as oral permission.
And then secondarily, before touching on the riparian buffer width, is just to encourage everybody to be safe. And when you're doing this walking, if you do take on the habitat, is that you go with another person.
Also a great point.
And I say that because yesterday we went out, we had 3 people, and one person was so stuck in the sediment we had to literally give them help to pull them out.
Wow. Yep, so those are great things to heed, and again, I totally support that and highly recommend that for everybody, and make sure that that gets put up on our website as well.
And then to just return to the riparian buffer width, really you're standing in the stream and you look laterally out. Do that a good number of times as you're going over the whole length of the station. So you're giving just a good general approximation of what that riparian buffer width. And if it's in a zone where you're arguing between, say, fair or poor, maybe fair or good, you will have to make a judgment call, and just try to justify it in your mind that because sometimes telling the difference between 5 meters and 4.9 meters, that's pretty difficult. But again, this is an overall estimate of riparian buffer width.
And that's a good point. When you're entering your data online, you're only going to have a drop-down choice. It's going to show up as 15, 10, 5, or 0 for this less than 10 form. So you won't be able to pick halfway between the scores that are shown there. You're going to have to pick one and go with that. Okay, I'm going to move on to the next one. So the less than 10 meter form, banked erosion. So we're looking at the bank. So this is one of the terms I didn't discuss, but thinking of it, land next to where the water is. Usually I think of it as vertical, but it could be not a steep bank as well. So we're looking at the width of the soil on the bank along the transects. So again, this transects, so these are places where you might have assessed your stream width as you move up the 35 times the length of the stream width. So they don't have to be specific transects, it's something to carry over from the quantitative habitat assessment. So your excellent would be there's not significant bank erosion. Good is there's limited erosion. Fair, moderate, or poor, there's extensive erosion. Greater than a meter of bank is bare soil. So when you guys are assessing bank erosion, or with the measurement of the amount of bare soil, so you're looking at that at the end of a transect. Is it looking sideways, or is it looking up and down?
Well, this is Craig. To assess it, say you're on your transect, or just anywhere you stop in the stream as you're progressing up, you look laterally, literally at the bank. So if you're in the middle of the stream, you turn to the left and the right and just look at the banks. And you're doing that multiple times as you progress through the station.
Okay.
And as a tip, you can use bring along a meter stick and literally occasionally measure. Or another trick is to, assuming you're using waders to wade, is to literally maybe put some tick marks on your waders for each foot or each tenth of a meter, and then you can. That gives you a good way to measure that.
I like it. While Craig was talking, I had a chance to look back at some of your questions. So let's take a minute and go back to a question about stream width, asking at the water level, bankful level, or some other point. So you want to measure stream width from water's edge to water's edge. Is that correct, Dave and Craig?
Yes, that's right, the wetted water surface.
Okay, thank you.
And when you're doing that, that should be generally normal flow. You don't want to do it at high flow or higher water conditions, and conversely on shallow, dry conditions.
Okay. And then a question about if the stream is braided, where there's multiple channels, would your stream width be adding together the 3 channels, or however many channels there are? Or would you look just at a single channel?
Exactly that, Chris. You would add up the wetted surface area of the braids themselves and add them together.
Okay, great. And then the last question has to do with the riparian conditions and one side being disturbed and another side not being disturbed. Would you just take an average and kind of lump together everything into pretending it's all one riparian area, and then you say, okay, it's about half of it that way, or is there something else you would recommend?
That's a good way to do it, Chris. I like that. It's again, you're averaging, so take the average.
Okay. And I think the last question I see up here, I think Dave answered earlier with the widths don't necessarily have to be equally spaced, but they should be spread out along the length of the stream at some distance. So you can try to get an average over time, but they don't have to be equally. It's qualitative. So don't worry about being exactly a certain amount of distance apart between the transects. Good questions. Okay, so I'm going to move on to the pool area. And for this one, it's the percent of stream length that's pools. So are they common? Are they wide, deep, low velocity habitat? This is interesting to me where there tends to be a highest score for when you have about 40 to 60% of your station as pools. And then it's not necessarily that it could be greater than or less than that, so the pools are present. They're not frequent or overabundant. You've got 30 to 39% or 61 to 70%. Or they're present. Either they're very rare or the whole thing is almost all pools. Or there are no pools. Or pretty much it's one big pool. So you have less than 10% or more than 90% of the station as pools. Do either of you have anything you wanted to add about pool areas? I think that one, to me, feels pretty straightforward, but if there's something when you're assessing it that you've run into that you think would be helpful for people to know, that'd be great.
Any thoughts on this, Dave? Otherwise, it does shake out pretty easy in that the excellence of the pooler are very self-evident.
Mm-hmm.
And then it's usually between the good and the fair.
Okay.
Chris, this is Janice, and I just wanted to point out to Dave that his mic is not active, so if he was trying to respond, he would need to click the talk button. I don't know if he took it off intentionally. Anyway.
Thank you.
Thank you.
Yeah. Yeah, I'll add go back to the previous slide quick, if you can, Chris.
Oh, okay. There you go.
It's first off, it's nice to have the sheet. It really gives you some insight as to what we find as quality habitat versus poor habitat. You know, you don't want no pools in a stream, and you also don't want all pools in a stream. You want a mix of habitats. So for adult game fish, having a 40 to 60% of the station as pool habitat is good for adult game fish. That provides them some cooler, slower moving water habitat that they need. So I guess I'll just point that out. And then I picture it as if you drag the tape measure all the way across your station from where you start to where you end, how much of that tape is in a deep pool setting. It's not how much of the stream width is in pool. It's just over the entire length of the station is in pool habitat.
That's great. Thank you. Okay, so then on the form we have the width to depth ratio. So this is the average stream width divided by the average Allweg depth in the runs and in the pools. So I think as Craig was just mentioning, if you marked your waders where in sort of depth measurements, one of the things that one of the other biologists had suggested that he does is he just walks the stream. So long as it's safe, again, that's prime importance here. If it's too deep, if it's going over your hip boots, please don't do it. But if you are able, you could walk, and then as you walk the length, station length, then you can assess the depth of this Allweg and the pools based on what you have these measures on your waders. One way of doing it. So the ratio, if your stream is very deep and narrow, you get a low ratio, so you get a high score. If it's relatively deep and narrow, you get a ratio 8 to 15, moderate 16 to 25, or if it's relatively wide and shallow, you'd get it greater than 25. Any tips from you guys on this one?
This is a cumulative sort of sense to it. So you can do the tick mark trick, or when you have walked the whole section, you might have a sense of where the average depth was on your hip boots or waders, and then you can just measure to that point.
That's nice.
That's almost typically what we do.
Nice. I like it. Thank you. Okay. And then the next one, another ratio. We've got riffle to riffle or bend to bend ratio. So we want to know the average distance between the riffles or between the bends divided by the average stream width. So this would be, if you've got lots of diverse habitats, the stream is meandering like streams like to do, there's deep bends, there's lots of riffles, low ratio, high score for habitat. If you have something where that's diverse but not quite as diverse as the most diverse areas, then you get your good score. If there's lower habitat diversity, there's only occasional riffles or there's only a few bends, probably a more straightened stream, you're getting a higher ratio and a lower habitat score. But if habitat is truly monotonous and there's hardly riffles or bends and it's really a straightened continuous run, then you get a high ratio and you'd get a low habitat score. For this one, any suggestions from either of you?
The definition of a bend, one way to look at it is if you're proceeding in a direction, and then you, as the stream bends, you literally have to change to a 60-degree bend, so to speak. And then it should come back around the other way. If it's anything less than that, say it's a 20-degree bend, which is just sort of a slight change in course, you don't want to take that as a bend.
Okay.
Again, it's 60 degrees or higher.
Okay, great to know.
And sometimes it helps to call up the aerial photo. If your county has aerial maps, or get on the DNR viewer, and then you can get a look at the stream that way. And you'll be able to tell the bend ratios that way.
Oh, cool. That's something that might be available through the Surface Water Data Viewer as well. Yeah. I think the aerial photos can be turned on. So a couple questions that came up. Oops, go ahead.
One thing I'll add, it's really nice if you've got a small stream that you're doing this habitat assessment on, and you're at 100 meters, the minimum length. If you got more than 10 sets of riffles or bends, you know right away it's a 15 score. So those are usually pretty easy.
That's great tip. Super. There's a question up here about there's mowed yards on one side of a bridge and there's woodlands on the other side of the bridge. So the question is, do you assess half on either side of the bridge? And I'm going to let you guys, Dave and Craig, answer the question. I have an answer that I often give, but I would like to hear you guys' opinion on it before I.
I'll take a stab at it, Dave, if you disagree. I might say one half of the stream would be wooded, the other half developed. So 50 wood, 50 developed.
Yeah, and so I think the recommendation in terms of choosing sites, so in general, we like to think of sites being located upstream of bridges because they're less impacted upstream of bridges, but not every site is located upstream of a bridge, so that's okay. So I would say it's your choice of where you call the station. If you start the station at the bridge and only go downstream from there, that's okay. Or you could do and split the difference as you said, the 50-50. And then the similar question actually has to do with having a. Okay, thank you. Similar question has to do with a culvert. So that's kind of, if you could say, a culvert or a bridge. So you can choose where you would create your station. Guys, would you exclude it from the stream width where the culvert runs through, however?
Almost a judgment call, depending on the size of the stream. If it's a tiny little stream and the culvert's 30 feet long, then definitely don't include it in your 35 times. But if, say, your stream's 3 meters or in width, so or larger, and as long as the culvert isn't significantly long, you could include it. I wouldn't be too exacting on that.
Okay, thank you.
I don't come across that too often. Just where if you go up from a bridge crossing or a culvert crossing, it's rare where you would actually come across another culvert within a particular qualitative habitat survey station.
Okay.
Although I should jump in and say that's in Dave's area. I'm a little more developed down here, so Scott is he might be running into some culverts.
Okay.
Makes sense. And then what about if you're sinking in the silt? What do you do? What do you call depth then? Or are you trying to estimate how much you're sinking and subtract that from your depth?
Well, bear in mind that this habitat estimate is almost from a fish's eye view. Generally assesses overall fish and same macro invertebrate habitat. So generally use the surface of the sediment up, not how much you sink in.
Okay, that makes sense.
Just because fish wouldn't have access to anything that is below the silt line.
That makes good sense. Okay, I want to move on to the next question in the form. So it's fine sediments. So again, these are your sands, silt, and clays, these very small materials that are making up the substrate of the bottom of the stream. So are they rare or absent? That would give you an excellent habitat score. If they're present but generally in the margins or in the pool areas, making about 10 to 20% of the stream bed, that would give you the good score. If they're common in the mid-channel, they're present in the riffles, and extensive in the pools, about up to 60% of your site, then it would get a fair score. And then if they're extensive across the stream habitat that at your station, greater than 60% of the stream bed covered, then you would get a poor score. Anything either of you would have to add about this one?
I'll say that right off the bat, there's certainly parts of the state that it may be true where you find finds rare or absent less than 10%, but in the vast majority of Wisconsin, you're not really ever going to see this, or it's pretty rare. Maybe Craig feels different, but you're almost starting at the good level here, because there's always there's some sedimentation, at least in the margins, in a lot of the Wisconsin streams. So just bear that in mind.
We don't have our mountain, so it is okay to not have that. That's a great point. Okay, and then for cover for fish. So this is the percent of the stream area with cover in or overhanging the water, that the water has to be at least 8 inches deep, 0.2 meters deep, because we're thinking of game fish here who have to have enough water to be able to swim in. So we're thinking about cover that is in water deep enough for them to be present in. So is there cover and shelter? So one of the ways this was explained to me many years ago is thinking of something about the size of a toaster. It could be cover, whether it's a log or a rock or some overhanging vegetation. So is that abundant, greater than 15% of the stream? Is it common but not extensive? Occasional, where it's only about 5 to 9% of the stream? Or is it rare or limited, where there's less than 5% of the stream offering such cover for the fish? Is there anything in particular that either of you do when you're assessing the cover for fish that you'd like to share?
That's a good summary. I don't have much to add there.
Okay.
I like the toaster.
Yeah. I often am thinking of toasters and streams when I'm out there. Maybe I'm hungry. The question has to do, does the cover include aquatic plants? And I would say yes. Would you guys agree with that?
Yes.
Yes.
Yep.
Okay. And then there's one other question. Is your normal monitoring site considered the center point of the entire station length? I think that's your choice. You could say you could put it at any point in the station length.
With one suggestion or qualification,
Yeah.
A lot of times in my experience, the points are established, say upstream 20 meters of a bridge.
Yeah.
And in which case, it's usually the beginning of a station, then you proceed upstream.
Okay.
And if you were to go up and downstream, then you'd be including that bridge and the associated impacts in that.
Right.
So overall, I would recommend having that, assuming it's close and you can get to it, is proceed in an upstream direction.
Okay, so if possible, we want to go upstream of the bridge and ignore that. And I know in the Urban Road Salt Monitoring Project, we have done the opposite, where we say, okay, we're going to go downstream of the bridge to see what the impact is of road salting. But in general, I agree, most of the stations are for the volunteers would be upstream. Okay. And then for the greater than 10 meter, greater than 33 feet wide assessment, there are fewer questions, and some of them are exactly the same as the less than 10 meter. So in the next couple slides, I'm not going to go back through the ones that we've already covered, the riffle, or bender and ratio, the cover for fish, because those are on both forms. There are slightly different scores that you get when you're using the greater than 10 meter form versus the less than 10 meter, so that you can end up with the range up to 100 for both, because there's fewer questions, but the question itself is exactly the same. It's just the scores are different. So the first one that's different on a greater than 10 meter form is bank stability. So we want to know the percent of bank that's protected by rock or vegetation. Is there no significant bank erosion? This is actually very similar to our old habitat assessment. No significant bank erosion, more than 90% of the bank is protected, and there's less than 10% bare soil. Get an excellent habitat score. Is it that there's a little bit of erosion, 70 to 90% of the bank is protected, moderate erosion, or extensive erosion? So again, in this case, you're going to average together your left and your right banks. The next one, the maximum fall leg depth. So we're looking at the average of the 4 deepest depths recorded. So are the stream, is it very deep, greater than 5 feet? So I hope you didn't walk through it at that point. Is it relatively deep, moderately deep, or relatively shallow? And so a little bit of clarification on this one. I think, Craig, you had said that you kind of walk and make a judgment after having done the whole walk. So is this something where you actually are taking 4 measurements, or are you walking the whole thing and saying, okay, this is the point where it got to on my waders, or I know I couldn't go into that pool because it's over my head, or whatever? Are you doing kind of a judgment without making those 4 measures, or do you recommend making 4 measures?
Generally making the judgment.
Okay. Okay. I don't see any new questions coming up, so I'm going to keep moving through. Oops, it's in here. It was hidden. We'll keep going. We talked about it before. So the rocky substrate. The percent of the substrate by area that's either bedrock, boulder, rubble cobble, or gravel. So these bigger materials that we talked about earlier. So is there extensive rocky substrate? And what Dave just said, maybe we'll have to see. I suppose there are some places that have extensive rocky substrate more than 65% of the stream bed, or is it something less than that? Is it moderate, 45 to 65%, limited up to 44%, or is there not so much rocky substrate in the stream bed, less than 15%? So do you guys think, Dave, do you think, can we get excellent? Or is that pretty rare?
Oh yeah, you could have excellent, I would say, here more than streams without any fine sediment, or fine substrate.
Okay. Fair enough. And then we talked about cover for fish. So let's see, we have one more question. How many fouling depths do we measure in the under 10 meter section? So the average, so this is one I'm pretty sure what we said is for the fouling depth, this is one where you just are kind of making a judgment call where you're walking the whole length and then you're trying to figure out kind of on your boot or as you went kind of what the average was as you went. So it's not that you have to do a certain number, it's putting it all together after you've walked that length or gone along that length of stream. Does that sound okay, guys?
Yes, that's right.
Okay.
Okay,
so the thing that I really...
I would say if you feel that you want to, we're not going to turn away you doing that, taking a set of measurements as you go, or come back down after you've walked the whole thing just to kind of verify what you're thinking. That's fine, but there's no set number of measurements you have to make.
Okay, thank you. Yeah, so one of the things that I really like about this DNR qualitative habitat assessment is we actually have a way of interpreting the results, whereas in the old habitat assessment we had this funny range of scores, which was 13 to 52 in the old one, and then we kind of had to go over time and say, oh, you know, what does that actually mean? And you could only compare your one site to that site in another year or sites that are nearby. But in this one, the person who put it together came up with a way of scoring water quality. And it's sort of like, I guess, a school exam where you get excellent water quality rating if you've come up with a score of more than 80, good if you're 60 to 80, fair if you're 20 to 60, and poor if you're less than 20. So you have an immediate result by summing up your questions, the answers to your questions, to come up with this range of scores. And I think I only have one more slide, which is our curious girls watching us do some streamflow monitoring a few years back. So with that, I will open it up to Dave and Craig if you have anything else to add that we should have covered, or if anybody has questions that you haven't asked as we've worked through. We're happy to have the guys speak more up or answer questions that you still have for anyone who's out there.
Well, as background, when DNR biologists, we used to do quantitative habitat, where we'd go out to a station, we'd measure out the mean stream width, do the 12 transects, do along each transect, do 4 different locations on that transect. So it was very data intensive, and we did that for a good number of years. And we switched over to this qualitative habitat for most monitoring over the last couple of years. And one of our scientists in the Science Service Department did the work to look at both methods, qualitative versus quantitative, and it was a very positive correlation between the two. That this qualitative information that all you volunteers will be gathering is just as or very near the quality that a hardcore quantitative survey will do. So this is going to be great information, and it's solidly backed up.
That's great to know. Yeah, I think it takes you couple hours to do a quantitative assessment. Does it not?
Yes.
Yeah. So that's awesome to hear that the research has been done, and that's where this came from. And you all have been using it for a few years? 3, 4?
At least 4.
Okay. Are there any other questions from anyone out there who's listening that we can address? Or if not, we will say thanks again for getting on, for learning about it. If you do have questions, feel free to let them know. There is a question just popped up. This is supposed to be done on each stream 1 time each season. Yes, if you can, if it's safe, if the length is not too far in terms of your ability to move up the stream, landowner permission, and safety and water depth, then yes, that would be the goal, is 1 time on each stream each year. And sometime June, July, or August are great times. Once the grasses and the vegetation has started to show up, early spring would be not a great choice. But once the vegetation's out, that's a great time. Any other questions? All right. Thank you very much, everybody, for getting on. Thank you, Dave and Craig, for giving all that great insight, and safe monitoring season to everybody. As we move through, we got some rainy weather. I'm not sure what people's streams are like. I know they've been high, so please be safe, and thank you very, very much for all your monitoring. Just as one more, just final closing. Folks who have questions about our online database, the programmers are now working on getting that set up, and we are pushing hard to try to have that up and running for you before the end of this month.
And thank you, Chris, for putting this together. And
sure
thanks
thing.
to all the volunteers.
Sure thing. All right, have a good Friday, good weekend, everyone.